In this short demonstration, I'll show you how to find the vector projection. Let's say that you have two vectors, v and w, and they're both non-zero vectors. To find the vector projection of v onto w, for example, it's mathematically represented like this, where you take the dot product of v and w, divide it by the magnitude of w, raised to the power of 2, and then you multiply that by a factor of w, which is the vector itself. That being said, question 1 reads, if vector v is equal to 2i minus 5j and w is equal to I minus j, find the vector projection of v onto w. Let's start by finding the dot product of v and w, this part. The dot product is found by multiplying the x components together and multiplying the y components together and then adding them up. So we'll take 2 times 1 plus negative 5 times negative 1. 2 times 1 is 2, and negative 5 times negative 1 is positive 5. So we just found the numerator. And then we'll take this and divide it by the magnitude of w. To find the magnitude of vector w, we use Pythagorean's theorem. Let me show you what I mean. The magnitude of w is equal to the square root of 1 raised to the power of 2 plus negative 1 raised to the power of 2. 1 plus 1, that gives us the square root of 2. If I square this, I'll end up with 2. So we found this part and this part. Let's go ahead and divide the two. We have 7 divided by 2 multiplied to vector w. Now to multiply a scalar by a vector, that's easy. You'll multiply this part and this part, both components, by 7 over 2. This leads us to 7 over 2i minus 7 over 2j. And that is equal to the projection of vector v onto w. Let's move on to question number 2. In question number 2 they ask, let v is equal to 2i minus 5j and w is equal to I minus j. Decompose v into two vectors, v sub 1 and v sub 2, where v sub 1 is parallel to w and v sub 2 is orthogonal to w. Now since v sub 1 is parallel to w as given in the question, then v sub 1 is equal to the projection of v onto w. And from question number 1 we already have the answer, it's right here. Therefore v sub 2 will serve as the orthogonal vector to w. And to find v sub 2 we will subtract v from v sub 1, which we already found here. Let's go ahead and do that. V sub 2 is equal to v, which is 2i minus 5j minus both of these, and make sure that you put them in brackets. Let's simplify this expression. We have v sub 2 is equal to 2i minus 7 over 2i minus 5j, and the two negatives make a positive, 7 over 2j. Let's use our calculator to quickly combine these. We have 2 minus 7 over 2. That gives us our new x component, which is negative 3 over 2i and minus 5 plus 7 over 2. Our new y component. And there you have it. That is how to find the vector projection.